If pure water itself is neutral, how does an aqueous solution become acidic or basic? The first person to answer this question was the Swedish chemist Svante Arrhenius, who in 1883 proposed what is now called the Arrhenius model of acids and bases, which gave the basic definition of acids and bases. The Arrhenius model states that an acid is a substance that contains hydrogen and ionizes to produce hydrogen ions in an aqueous solution. And Arrhenius is considered to be one of the founders of physical chemistry. In Arrhenius' definition, a compound that contains hydrogen and when broken apart it produces hydrogen ions in an aqueous solution is considered to be an acid. An example would be HBr, hydrobromic acid, when broken down is a hydrogen ion and a bromine ion. Another example would be HCl, hydrochloric acid. When broken down, it becomes a hydrogen ion and a chlorine ion. Some properties of acid that help you identify them are they're sour, which means you could have seen them in daily life in candies like Sour Patch, or in orange juice, lemons, or vinegar. They conduct electricity, which makes them an electrolyte. They turn blue litmus paper red. The pH range is 0 to 6. All acids are soluble in water, and most acid solutions are corrosive, which means they eat away. They also cause a color change in the universal indicator.
Arrhenius' definition of bases. A base is a compound that contains hydroxide, OH, and breaks down to produce hydroxide ions in a solution. An example would be lithium hydroxide breaking down into lithium and hydroxide separately. Properties of bases. Bases, like acids, conduct electricity and cause a color change in the universal indicator. But they turn red litmus paper blue and have a pH of 8 to 14, and they turn phenolphthalein pink. Unlike as acids turn the blue litmus paper red, bases turn red litmus paper blue.
This is a pH scale. It helps you to identify whether a substance is an acid or a base. As you can tell, the closer a substance gets to the pH of 0, the more acidic it is. And as it becomes closer to a pH of 14, the more basic it is. Distilled water always has a pH of 7, which is neither an acid nor a base. Instead, it's just neutral. There are many household items that are acids and bases, like cola, orange juice, ammonia, and bleach. The household item that we're going to focus on is ammonia. Since it doesn't apply to Arrhenius' definition of acids and bases, we're going to perform an experiment to determine whether it's an acid or a base.
We begin our experiment by pouring ammonia into 3 separate beakers. Next, we add a few drops of phenolphthalein. As you can see, the phenolphthalein turns pink, indicating it's a base. When we add our universal indicator, it turns purple, indicating that our substance is a strong base. When we use our blue litmus paper, there's no change in color. However, our red litmus paper turns blue. Our pH indicator shows us that our substance has a pH of around 11. Last, we will test the conductivity. As you can see, the conductivity tester glows when it is submerged in the ammonia.
From performing the experiment, we have concluded that ammonia is considered a base, since we discovered that its pH is 11.79. Other indicators that it's a base would be that it turned red litmus paper blue, it caused a change in color in the universal indicator, it turned phenolphthalein pink, and lastly, it conducted electricity.